Uh, Welcome to our EECS final video demo. In the first part of this video, I'll be walking through some example user scenarios based on our primary persona. Our primary persona is Jim, who's currently a sophomore at the University of Michigan. He's a college student. He's living off campus. So each week he needs to perhaps make grocery shopping purchases to cook, but also to resupply his apartment. So he would like to use an application that helps him with managing his shopping list so that he can keep track of what he needs to buy for the upcoming week, and also to make sure he doesn't repeat buying things he already have. At the same time, Jim is looking for a software that helps him with making better financial decisions and helps him with budgeting. So perhaps an application that helps him with breaking down, the different prices and the amount he's going to spend on different categories is going to be really helpful for him to make better purchase decisions. So with that in mind, let's take a look at our application here, and we'll be walking through over the features he might find useful here. First, you see that we already have a list of items here on the cart, so which is costing us a total of $31. Maybe Jim wants to add something else to the list. Maybe he wants to buy like an iPhone for theoretically for in the electronics category for theoretically about $10. We can add this item to the list as such with by entering the name and selecting the category as well as entering the price. So now we can see the iPhone has been added to the list. You can see that different items are also color coded by their categories. So we can see that meats are color coded by red and toiletry are color coded by white, etc., and etc. So now this is how he might add a new item to the list. So now you can see that it costs a total of $41 to purchase everything on the list. But maybe he changes his mind. Maybe he doesn't want to buy a carrot. Instead, he wants to buy a banana for this upcoming week. So in order to do that, he just had to click on the modify button, which I had to click there, and then choose the fruits category, banana, and then let's say it costs $5. So you can see that he doesn't have to delete the item and re-add it all together. That would be a really poor user experience. You can do it all in one step just by clicking on this modify button here to change the item here on the list immediately. So now you can see that the total also reflects the new list that's being updated. So after this, maybe he will also find it helpful as the list grows longer. It'd be really helpful to be able to filter and search items by their category, since we might have, imagine hundreds of items on this list. So maybe Jim wants to visualize what fruits is he buying for this weekend, and if it's enough for him or his roommate. So let's look at the fruits category here. So you can click on the select by category filter here and select the fruits category, and you can see that the list now be rendered to just the fruits category items. So you can see the fruits he's buying for this weekend are banana and apples. Now of course, he doesn't actually have to use his drop down if he doesn't want to. He can also just search. So instead of just maybe it's too slow for him to look through all the options. You can imagine as the list grows bigger, it'll be more options there. So maybe he just wants to look at what he can search, type in meats, and see what options there are for this category. And you can see that he's buying a steak for $9. So this is a search and filter feature, and you can click to all again to display all the items once more. Now we'll see how he might check off some items that he's already finished buying and how he can make further modifications to the list. For example, maybe he's finished buying the toilet paper, the steak, and also the iPhone and the banana. Maybe he finished buying these 4 items. So as you can see, we indicate here that you can click on items to mark them complete. So he clicks on it and it has a check mark visually indicating that it's been completed. This signifies to the user that this item is now completed. And then you can see that there's another item button here at the bottom, which hovers and turns red when you hover over it. It says clear completed items. So once Jim finishes buying these 4 items, he checks them and ticks them. You can click on this clear completed button, which then would delete it from the list. And now the total would just be whatever item that's left on the list. Cool. Let's add some items back just so we can demonstrate our budgeting feature as well. So let's add some chicken to our list, and as well as some, let's say, carrots, which belongs to the vegetable category. And then let's add another, let's say, AirPods in the electronics category. Cool. So let's have some more items on the list. And now we're going to show off our spending page. As you can see on the top left here, there's a spending page button. So once you click on it, it will bring you to this numerical breakdown interface. So At the beginning, there's nothing to display because we haven't selected any category initially, but you can see that these colors kind of reflects the same color that is shown on the shopping list. So if you click on a pie chart here, you can see that electronics, which is this color gray, costs us $20, and then it's taking up 48% of our total budget for this weekend. So this is a huge purchase in terms of the weight of the purchase is very high in terms of this week's budget. So he can see that he's spending $20 on just the AirPods, and that's almost half of his spending for this weekend. And similarly, he can click on the other categories. You can see that chicken, which we just created there, costs $12, and then it consists of 29% of his budget. And then similarly for carrots, fruits, these are all different categories. Let's add another item here just for demonstration. So let's say we want to add a steak back to the meats category. You can see that now the weight has changed, and this is now consisting of the majority of the spending. So as you can see on the right side, we actually have the list name itself, the total, but also a data table here that shows the individual items that belong to this category. So for example, in the meats category, we have both the steak and the chicken with their item and price. We can also sort the prices in the table by clicking on this sort button here. So you can see which items actually cost the most in each category, and that helps you make decisions about which items to keep and which ones to leave out. So this is how the budgeting page works. Basically, you can visualize all the spending he's making this week, and then it helps him break it down into chart. And then once you click on the chart component, it pops out, so it indicates that you're selecting this pie chart currently, this sector here. And then on the right side, it's going to display the actual information, so of what you're actually purchasing and which belongs to this category. So the data table and the prices. So after this is done, he can visualize all the features, and he can make decisions about whether maybe after he sees that the meat is taking up way too much space, way too much cost. So maybe he goes back to click on the back button to go back to the main page, and he maybe says that the steak is not for this weekend. He can remove it here, and that's how you delete an item from the list. So this wraps up kind of the feature walkthrough of our program. Hi, welcome to the second part of our video. In this section, we'll be going over some of the higher level technical details that's relevant to our project. So on the front end, as you can see, everything here on the interface is implemented using React JavaScript. We also use a mix of native CSS alongside emotion CSS, which are object-based CSS. Basically, we do a lot of styling with our components using these techniques. Each feature, like for example, the add to cart, the spending page, the filter, the items, the clear button, they're all its own unique module and own component. We utilize this highly modularized and object-based method because it's much easier to do task assignment and break down the massive tasks that's at hand. So for example, somebody might be responsible for implementing this feature, this module, this component. So having different components and breaking down the tasks into different modules really helped with task division, and also later on code integration, because we're focusing on integrating two components at a time instead of everything together. So this method of organization helped a lot with assigning tasks, integrating code, and also making everything much easier to structure and much more neat and structured. This also helped a lot with unit tests later on, because highly modularized components made much easier sense when it comes to unit testing. We just had to write unit tests for this module. So also in terms of testing, it was a lot better. It was a lot better of a design decisions to make component-based features. Now to go a little bit more into detail about the features themselves. So for example, you can imagine that an item here is also a component itself, but it belongs to a parent component of a shopping list. So the parent is responsible for making modifications to each child component. It calls so the parent actually keeps track of the states of the children and makes modification to them. In this case, in this way, we enforce a strict dependency between the data, so we aren't really making modifications when they shouldn't happen. So in this way, we ensure that there's only a single source of truth. The search and the filter feature is done using an open source component called React Select. So the native version of it isn't quite enough for our purposes, so we had to make some modification for it to be able to search by our category, and also the ability to search was not really immediately available. We had to add that to this feature itself. So the search feature was indeed an addition and a modification we made to the React Select. And what it does is just helps us to filter items. And for the add to cart is another component that I mentioned before. So we've grayed out the background, and then so that we put the focus onto the pop-out window. We also enforce some type checks, so you can't really type any letters in here. They only accept numbers in the price, and for name is more flexible, but we also do some sanitation check to make sure that we're sanitizing the input, and these are just good software practices, just so that the user inputs appropriate things. And then if you try to leave things empty, it's going to enforce you to typing something, because that would not be allowed. So we do a lot of type checking to make sure that we are abiding by the standards and protocols. And lastly, for the spending page on the high level. So spending page is done using two major React components. They're called minimal pie chart, which is responsible for displaying this pie chart here, as well as a React data table, which is responsible for rendering these data on the right side. So similarly to before, they're not quite sufficient for our purposes. So we had to make modifications so that, especially with regards to data processing, because originally these modules, they were expecting data in a different format and different structure, much different from how we structure our data, which is very much object based. So we had to do a lot of parsing of data to make sure that it would be parsed properly and correctly by these modules, and then thereby they would render it correctly and display the correct information and the correct data types on the list here. So yeah, basically we used React minimal pie chart and then made modifications to it. So then also, like for example, this pop out feature is something that we added ourselves, so that it's more suitable for our purposes and needs. And similarly with the data tables, we included this code, and then we made modifications to it so that it would display the data in the way we want to. So this wraps up the very, very, very high level technical implementation of our oh, hold on, sorry, I also got to talk about the backend for a second. So which is actually quite important. So we use Firebase to host our database on the backend. So Firebase is a NoSQL database, and then initially in our project we decided to go with a SQL database, but then after getting more work done and getting to know our code better, we realized that a NoSQL database is a lot more suitable for our needs and purposes, because the way we structure our data is already very much like how NoSQL databases structure their data and entries. So you can see that each document, it contains different fields and with different values. That's exactly how we structure our data on the front end. So an object contains different attributes with like names, prices, etc. So doing integration with the Firestore database with a NoSQL database in general was a lot more smoother than with a SQL database, where you had to create different type of data entries and data tables and do a different type of merges. It was a lot of extra work that we didn't have to do. So we decided to change our plan and switch to a NoSQL database, and then it worked out really great because of the queries we did were very simple queries, and they were much easier to do on a NoSQL database like Firestore. Because we're more interested in just deleting, adding items, and by their ID usually is all we have to do. So we didn't really need any complex database operations, and a NoSQL database was perfect for that. It was much easier to do, much efficiency-wise, probably also better. So that's why we decided to go with a NoSQL database like Firestore. In addition, we also weren't expecting much load. Like we have very minimal data set. As you can see here, we have 5 documents which reflect the 5 elements that are displayed here. There's a very few read and write operations that really happen. Given a single user, given like hundreds of users, it would be quite minimal. And Firestore was really great both for small scale projects, but for scaling up. So I think we just have to maybe do a different subscription plan to handle higher loads. So Firestore was really an excellent choice for doing small scale projects, but it will also be really good for scaling up our backend as needed. Whereas writing our own backend would be a lot of extra work that would be not as scalable as Firestore. So yes, so this is how we integrated this is why we chose Firestore to integrate with our front end interface, and why we chose NoSQL database on the high level. Welcome to the final section of our video. In this section, I'll be talking about the challenges, some of the challenges we faced while implementing our application and how we address them as a team. First of all, one of the most difficult parts, despite our good organization in terms of modularization and making each feature into its own component, integrating our code between different team members was still quite challenging. Mainly because despite the problem being stated clearly, we had different interpretations of the way to solve them, as well as some of the data types that the way we interpret it. For example, I might interpret it this way, it's an object that's typed with these attributes, where someone else might think of it in a different structure. So there was a lot of like misunderstanding and misinterpretations in terms of how the data should look like, or like what this function is supposed to do and return. So this led to confusions when it comes to team meetings and code integration. The way we addressed this was we after we observed the problem, we set clear protocols and standards and good documentation that helps you state exactly what this function needs to do and what it needs to return, the data types. In essence, it's about like better documentation that clearly explains the necessary technical details that helps someone else make sure that nobody is getting the wrong impression or the wrong interpretation of how something should work. So this helped us to standardize our understanding and uniformize our approach. So this is how we addressed the first problem and the first challenge we faced. Secondly, was a lot about incorporating as you can see, as I talked about before in the previous section, we use a lot of open source, and we imported a lot of open source to save on work, but also to make a lot of modifications to them so that they are more suitable to our needs. And integrating them was a big challenge because obviously a lot of these open source have pages of documentation, and we had to really study a lot to understand what they did. And more importantly, we had to integrate their processes into ours. So, for example, I talked about before how maybe they are expecting different data inputs and different data outputs than we expected. So we had to do a lot of like mix and match and make sure that our code functions well with the foreign code. And the way we did that was we did a lot of experimenting with different modules and doing a lot of research on their documentation to make sure that we understand what exactly they did. And once we did those, incorporating these code become a much smoother process. It still took a lot of time to understand these open source modules, but once we did, we were able to incorporate them and make them behave the way we would like them to. Another small issue that we ran into a lot was with types. So we are using JavaScript mainly, so it's not really a strongly typed language. A lot of the cases JavaScript would accept and compile on code that's not strongly typed. So sometimes we might be doing, like when we are adding numbers to the total, for example, we might accidentally do a string in the number addition, which turns out to be a string. So like a 4 plus 2 will become 42 instead of 6. So these like small type issues is something caused by like JavaScript being not strongly typed. And as you can imagine, with 3 of our team members working on this, if one of us makes this mistake, it kind of like goes into and like spread into other people's code as well. So typing was a really big issue because it kind of really messed with the computation part of our application, and especially given that JavaScript isn't strongly typed. So the way we address these like type errors that we ran into, which didn't really cause like compiler issue, but they were like they create like logical issues. So the way we did it was we enforced strict typing on our objects and in terms of documentation, and basically set standards again with our teammates. A better way to do this, if we had more time, was probably we would convert entirely to TypeScript instead of JavaScript, which is indeed a strongly typed language. TypeScript would, I think, avoid this issue altogether at the first place. But what we did was also sufficient for our project. We just enforced strong typing on the inputs and outputs, and also we did a lot of casting when needed. So just to make sure that we're not adding strings with numbers, and we're casting them to numbers first before we add them, etc., etc. So yeah, a lot of standards were set and a lot of casting were done to make sure that we address these errors. Lastly, this was probably the most important and the most serious issue and challenge we faced into was optimization. So when we first started to utilize Google's Firestore, we were bombarding it with like millions of API calls every minute. It was just ridiculous. And given our free tier plan, we like immediately like reach a limit within the first minute or so. So that was a really big problem because we couldn't, once we reached the free tiers limit, we couldn't make any more calls to the backend. So essentially we couldn't work without like upgrading our plan and paying money for it. So that really like was a big hindrance and stopped us, caused a lot of time to for that day especially. So optimization wasn't really a big issue initially before we were concerned with the backend. We were just like rendering components really quickly, and the computer was able to handle that without much problem. But once we had to make API calls to the backend, it really started bombarding their server. So for example, this list would be rendered like very very quickly, like every millisecond or so, and also each deletion and insertion operations, like deleting this item here or like adding a new item later on would be made like individually. So deleting this would be one call, deleting this would be two calls, deleting that would be three calls. So there would be like many calls for deletions, and that would be like really redundant work. So you can imagine that created a lot of calls to our server, to our backend server, which immediately like bogged down our server and made us unable to utilize the backend servers for that day. And this was a really big problem, so we had to hold an emergency team meeting to address it. We immediately made optimization to our code. Basically, instead of rendering our list every millisecond, we put a dependency clause for the React use effect rendering. So we made sure that we're only rendering when changes are made to the shopping list itself, instead of whenever instead before that it was rendering whenever anything changed in the page. So if trivial details change it will still render. But instead what we did was we passed a dependency array to it, telling it to only render when we make actual modifications to the list. So that helped a lot with reducing the number of rendering calls, which were bombarding the database with. So that helped a lot. Well, that was the first step in the optimization, by like just by reducing the number of renders only to necessary details. And also, secondly, we instead of doing like individual read and write calls, so instead of reading each element one by one or like deleting this item and telling the database, "Oh, delete this item for me," we did it in batches instead of singular terms. So what that helped a lot with like batch deletions. So if we select multiple items, then we wouldn't have to we just delete it in one call instead of like three different calls. So that was a smaller optimization, but it still helped a lot in terms of in the long term, especially considering if more users starts using it, this will become a really significant optimization. Doing batch calls instead of singular calls really also cut down the read and write requests to our server by a lot. So these are how we address some of the common challenges that we ran into and that we faced.